Tonight's topic is really just a logical extension of what we did yesterday. So I'll just go through some examples to make sure that you can see the connection. In the book, the examples are 2p minus 3, the absolute value of 2p minus 3 equals 7. Well, we already know if something has an absolute value of 7, that means that something is either 7 or negative 7, which means we can translate this to two equations. Either 2p minus 3 is 7, or 2p minus 3 is equal to negative 7. We solve, giving us 2p is equal to 10, which makes p equal to 5. Or, oops, I was jumping ahead in my mind. Or 2p equals negative 4, making p negative 2. Since these are the dots exactly on the line, that puts this at negative 2. There, that is a solution. I want that color in. And the other solution that we are graphing with a point or a dot is 5. Next example. We have 10 minus 2k, the absolute value of 10 minus 2k is greater than or equal to 6. All right, from yesterday's work, we know that if something has an absolute value greater than or equal to 6, that something has to be either greater than or equal to 6, or that something, in this case 10 minus 2k, has to be less than or equal to negative 6. So I'm glad we're doing this example because it brings up that evil thing that you have to be aware of, and that is if I divide by a negative number, then the sign switches. And that's going to happen again when we solve this one. I'm dividing by a negative number, so my sign switches. And the way that translates to my number line graph is I graph my critical numbers. They're both colored in because it's less than or equal and greater than or equal to. I put the 2 here, I put the 8 here. It's all the numbers that are less than or equal to 2, or the numbers that are greater than or equal to 8. Really all that we have here. I feel like there's something missing. What if I have something that looks like this? Let's just do one final. They don't even give an example for this, but I do want to take the opportunity to remind you plus 11 equals, plus 11 is, oh yeah, it is equal to, let's make it less than or equal to 19. Less than or equal to 19. Okay, so this has a lot more stuff with it. Stuff that's beyond just the absolute value part of the equation or inequality, which is right here. So just like always, we have to isolate our variable. And before we can do the absolute value part of this, we need to get rid of all this other stuff. So let's first subtract 11, leaving us 2 times the absolute value of 3k minus 7 is less than or equal to 8. And now this is still in there as a part of the equation that's not in the absolute value. So we're going to divide by 2, and we're going to say 3k, the absolute value of 3k minus 7 is less than or equal to 4. Now, I know that if something has an absolute value less than or equal to 4, then that something is less than or equal to 4 and that something, and notice I say and because it's going to be a conjunction, is greater than or equal to negative 4. When I solve this, I get 3k is less than or equal to 11. And you can just leave your fractions like this, 11 thirds. So k is less than or equal to 11 thirds. And k is greater than or equal to 1. So here's where that is on the number line. As we all know, 11 thirds is 3 and 2 thirds, so it's greater than 1. So our 1 goes here, our 11 thirds goes here, and it's all of the numbers in between because it's the numbers less than 11 thirds and the numbers greater than 1.